Welcome to Next Gen Data Development with the DBT Fusion Engine. Thank you all for joining us right after the keynote. We're also excited to have you here and take a deeper dive into some of the cool things you just saw on the main stage. My name is Venkateshwaran. I'm a software engineer here at DBT Labs, and I primarily work on the Fusion Engine.
And my name is Benoit Perigaud. I have been with DBT Labs for 4 years now, and I'm in the developer experience team.
Today, we're going to talk about a wide array of things, starting with what is the Fusion Engine, and talk about the roots of where it came from. We're going to talk about how Fusion elevates the local developer experience. We're going to talk about how Fusion will supercharge the platform experience. Then we'll leave you with some sneak peeks into all the really cool things that we can build on top of this new platform that we have. So you might be wondering, what is Fusion? Probably not, because you just came from the keynote, and we just gave you all these cool demos about what Fusion is. But at a high level, Fusion is a brand new engine beneath the exact same DBT authoring layer that you all know and love. It's the same DBT project structure, your YAML files, your SQL files, your refs, sources, configs, the same packages, everything that you know and love. However, the inside is what's different. To kind of understand where this comes from, we have to take a little bit of a journey back into the past and look at January of 2025. Earlier this year, DBT Labs acquired a company called SDF Labs. SDF is a place where myself and my colleagues were working on the first generally available multi-dialect SQL compiler. Our friends here at DBT Labs thought this technology was super innovative and super interesting and wanted to help us bring it up to as many people as possible. And that's what we've been doing for the better part of this year. We've been collaborating and working together to bring this technology to as many people as possible. And we're so excited to have you all here with us on this journey. Along this journey, we've had to completely re-platform DBT Core in Rust, leveraging Apache Data Fusion and Apache Arrow, and integrating SDF's native SQL comprehension technology to make DBT much faster and smarter for all of you. So there's one major fundamental difference between DBT Core and Fusion, is that DBT never tried to understand your SQL because SQL comprehension is a very, very challenging problem, and DBT chose not to tackle this until now. So when DBT ran compile, it would take your Jinja templates, it would render them, and then it would have to ship these templates off to your warehouse in order to actually get any sort of feedback on whether your SQL was correct or not. This is a very slow and tedious process in order to find out if the SQL that you're authoring is correct or not. Well, Fusion is a SQL compiler. And what that means is we're actually able to parse your SQL statements into an abstract syntax tree, or an AST. We're able to then bind this AST into a logical plan, which is a very similar representation to how your database will actually validate and execute your SQL query. And so with this AST and logical plan, we're able to validate your SQL for both syntactic and semantic correctness. And what that means is, given the SQL dialect that you're using, are you using the right keywords? Are you authoring syntactically correct SQL? And then B, are you actually querying the underlying data that exists in your remote warehouse? Are you querying against the columns that exist in your tables? And are you passing in the right data types into the functions for the SQL dialect that you're using? And this is something that no other tool has been able to do before now. So if we're able to dissect DBT into two layers, there's the authoring layer on the outside. Like I mentioned earlier, it's your DBT project file, your YAML files, your SQL files, your refs, sources, configs, the packages, the whole works. This is what you all know and love. It's what thousands of teams use all over the world. It includes the DBT packages. And this is battle tested and scales very, very well. We see so many people rave about the DBT project structure. And then if we were to look at the inner layer, this is what we call the engine. The engine is where all the work is done on the inside. It's where the dependency resolution happens. It's where the Jinja templates are rendered. And it's how we talk to your data warehouse. This is what we've noticed has not scaled well over the years. I'm sure as many of you have noticed, as your projects have ballooned in size, as your data needs for your business have grown, DBT has not grown with those needs, at least the engine has not. And this is where the replatforming comes. We've rewritten this engine in Rust to make it significantly smarter. Like I mentioned earlier, we've replatformed around Apache Data Fusion and Apache Arrow, and we've integrated SDF's native SQL comprehension, and hence we have the DBT Fusion engine, which is a fusion of the DBT authoring layer and the SDF technology to make DBT smarter and faster for all of you. So what have we done so far? Earlier this year, at the end of May, we launched in private beta we came with the Snowflake adapter, we came with all the fundamental commands that you all know and love and need on a daily basis, and we came with default materializations. Since then, we've fast followed with multiple more adapter support. We've launched exposures, cloud CLI credentials, and custom materializations. It's been a very, very long road so far, and we're very proud of how far we've come. And we're so happy to have you all on this journey with us, and we're so excited to ship more features that allow more and more of you to try this wonderful new platform. Next, I'll pass it off to Benoit.
Thanks, Annie. So we just talked about the Fusion engine, what it is, how it's been created. Now let's talk about how you can use it. We've seen it in the keynote. There are different ways that you can use the Fusion engine today. Locally, there are two ways. So one of them is using the VS Code extension. This is a proprietary piece of software that we have at DBT Labs, which is free to use up to 15% per company. And we have also a CLI, which is source available and then free to use for anyone. Like Elias as shown in or as talked about in the presentation, so the extension covers a wide array of use cases. And even though we call it the VS Code extension, it works in any, let's say, VS Code-based IDE, so Cursor, Windsurf, Kiro, any of those IDEs. And now I'm going to show you another demo, so following up Elias' demo this morning, another demo of how this VS Code extension can help really make the developer experience much better and stay in a flow state. So here we have like a project, which is a project where we are combining Jaffel data and Flower data. So I am in a project here, and what I'm doing is I am unioning data from the two different tables. In the extension here, if I click on the code button, I can see like the compiled SQL, which is like the compiled version of my model. I can see directly that the compiled code for my macros as well. So this is working out of the box. And one of the great use case and the great like experience that we have here is that if we update our file on the left, we save it and it's showing straight away on the right. Like in comparison to like a DBT compile that we do in DBT today, it's like 10 times faster. So we can see the compiled SQL very, very easily. Another thing we can see is also like the types of the columns. So here I can see that I have some varchar columns, another varchar column here. So everything here is driven by the Fusion engine. It also works for macros. So Fusion understands the type that the macros are going to generate. So this is very, very useful. If we jump to the lineage, we can see the lineage at the model level. So this model, dim customers, depends on a few upstream models. And we can even look at those from like a model type point of view. So here we can see which one is a view, which one is a table. Very, very easy to understand, like if you have some bottlenecks in your data, maybe it's because you have too many views, let's say, chained to each other. What we have as well is the column level lineage, which is very new in comparison to DBT core. Here, I'm looking at the column level lineage for one specific column, and I know that this customer key comes from like kind of two different streams or two different branches of data. One of them is the Jaffel one, and one of them is the Flower Shop one. So we can see that the whole flow of what leads to this column. In my case here, what I wanted to do in this demonstration is like add a column. So I'm just taking my model here, and the VS Code extension is going to automatically tell me what are all the columns available for this specific table. So I'm selecting customer email. And if I save, we'll see that Fusion automatically understands that there is an issue. Like I just saved and it just came out directly. So the issue is I am using a union all when using a select star. So now these two cities have different columns. It doesn't work anymore. So Fusion tells me this out of the box. I am now going to add a column to say that I don't have a customer email, so I'm just putting null. So I'm typing it now, I save, and now there is another error. What is this one? This time, there is a typo. I forgot to put a comma, like all the time. And yeah, like if you forget to put a comma, Fusion is going to tell you that there is a comma missing. So I add it, I save, and then there is no more problem, which means that without having to do back and forth with the data warehouse, like I know that this model is going to work. Right now, I'm previewing this city, and I can see that the new column that I've added, customer email, is already there. And yeah, again, like I do everything from the VS Code extension. I can run this model, and in a few seconds, it's going to be available in my data warehouse. So this is very, very, very powerful. Everything from one single place without having to jump to my data warehouse, without having to write a query by hand. And here, what I wanted to highlight is that Fusion also understands like complex types. So here, if you preview the first CTE, we'll see that there is some arrays. So Fusion understands types like arrays, like struct, like everything that is more complex than varchar or integer, it is supported in Fusion. So here we understand that this type is an array, so we can apply all the array functions to it, but we won't be able to apply, let's say, the integer functions to it. And the other example I wanted to show here is also Fusion understands like complex queries. Like here, it's a lateral flatten in Snowflake, which is a way to unnest your rows. Fusion is going to tell you if the way you've written it is not the way it should be written. I never know how to use lateral flatten. I don't know why, but Fusion tells me like, yeah, here I needed, like this comma was, with a comma it was working, and without a comma it was not working. And here, this is a quick demonstration of what Elias showed also this morning in the keynote, proving you that it works because it works twice. Here I'm going to rename a column, which is called size category to size arrangement category. And when I save it, I can see it directly in the downstream models automatically done, saving me, I don't know, at least a good 5-10 minutes in doing it by hand, just doing it from the VS Code extension here. So very, very, very quick, and a great flow of development that we get from there. And yeah, so we can see it's been renamed in the different sections. So what we saw here is that in the end, it is the same as the DBT we know. It's the same SQL we write. It's the same CT we write. But it's just that we now get all this context coming in straight away without having to jump to tools, without having to like look at the catalog to see what are the columns available. Like it is really helping the development cycle to make it much more efficient. And I think that what I showed in 5 minutes without Fusion would have taken easily like 15 or 20 minutes with DBT Core today. But what we showed was also what the team has been working on since May and for some time. The team has been improving on it, like Annie has been fixing bugs, they've been adding new features, but there's also like new things that we've added to the extension. So if you've not used the extension in the past few weeks, you might have missed like some of these things that I'm showing here. The first one is we've added like a flow to help with with moving from DBT Core to Fusion. As Christian mentioned this morning, the projects are very much compatible, but there is a few things that need to change sometimes to make it work, to make your project work both in Core and in Fusion. And we have now a flow that will help you do that directly from VS Code. We have DBT Compare, which I'll do another demo like Elias did, which is really a way to understand the exact impact of the change you're doing in a current PR, for example, and making sure that the output is really the one you're expecting. And one thing that is actually quite also interesting and has made my experience much better with Fusion in the past weeks is we released what's called like incremental compilation. So if you used the VS Code extension maybe a month ago or a bit more than that, whenever you were saving your file, you had to recompile your project all the time, which could take a few seconds and sometimes like for extremely large project like a minute or so. But since we have incremental compilation, whenever you modify a model, we just compile now the models that have been impacted by this, which means like it is nearly instant done in the instant, which means that even with large projects, you can definitely use the Fusion VS Code extension, and everything will work completely fine. You won't have to wait too much for the compilation to happen. So now, I'm going to show you again like the compare feature that we showed this morning. This is a bit of a different use case here, but we're going to go through a similar like kind of flow. So here, like the example I have is somebody in my team told me that there is some data that seems wrong in the final table. So I have this model called fact customer lifetime value, and they say that there are some customer IDs that look odd, and they don't understand why they are there. So I'm just previewing a city in there, as we can do in the extension, and then I see here in the customer ID column that there are some emails that were actually from some tests we did like a few weeks ago. We were testing the platform, and we have actually right now some test data in there. We don't want our test data in our fact table. So to fix that, I want to change my model so that I can understand what I need to change and then see how it's going to fix it. So I'm looking at the column level lineage here, looking that this customer ID comes from, similar to before, like two different, let's say, chains of models. And here I'm going to jump directly from this screen into the staging model for flower shops. This is a normal staging model. And what I'm going to do here is put a where statement so that don't select those test accounts that we had when we tested the system a few weeks ago. So here, this is something that we generally do in staging model, which is like, for example, removing your testing data. So I'm removing it here. I'm just adding a where statement to remove a few emails, which were my test emails from a few weeks ago. And now, from the extension, I can just build my model and everything downstream. So it is going to do like DBT normally does, which is like a run and a test and a run and test for all my models. So it does it, and which means that now in my own schema, I get all the updated tables that are like downstream of this model. Now I want to look back at this model that my end user mentioned had an issue. So this is this fact customer lifetime value. And to understand the exact impact of my change in the staging model to the final model, I'm going to click on compare. So clicking on compare, I am going to compare the data of this model in my schema versus this model in production. So we run compare. And this time, we'll see that I have like 3 primary keys that were removed, which means like 3 rows were removed from these fact tables, 0 row was modified, and no column was modified. We saw this morning that if you do errors in your code, like this might light up everywhere, but in my case, this is doing what I want. Like it is removing just 3 rows. I removed 3 rows from my staging model, and it removes 3 rows from my final model as well. And we can see here the number of rows in production and in the development, which is like just three different ones. If I go to primary key, now I can see also like the exact data that has changed. So this is very useful in some cases to understand like what is going to change from like a data point of view. So here I can see like exactly 3 rows are getting removed from this table, which looks very much like what I want to do with this PR. So going from there, I'm very confident that the change I've done in my staging model is the change that's needed for my end user. And I can confidently create a PR. I can even, why not, like put a screenshot of this compare tab to prove to my end user that what I'm doing is actually going to fix what they raised to me. And now Annie is going to talk to you about Fusion on the platform.
Thanks, Benoit. That was an awesome demo. So now we're going to talk about Fusion on the platform. So there's a bunch of different places where Fusion really supercharges the platform experience. You heard at the keynote today about juicy savings on your compute bill with state-aware orchestration. So we'll dive into how Fusion, you can configure Fusion to actually end up reaching those savings in your own projects. We'll also talk about how Fusion speed and static analysis really make using Studio Insights and the agentic workflows in the platform much more snappy and fun to use. So we'll start by taking a deeper dive at state-aware orchestration. And we have a brief diagram here to just walk you through what that looks like. I also encourage you all to attend a breakout session later this week, ran by Ruben, another PM at DBT, where he dives much deeper into state-aware orchestration. So if that's something you're interested in, I really encourage you to attend. So we have this DAG here, and there's 4 sources and a bunch of downstream models. Let's say the raw wizards table is updated with fresh data. Fusion is intelligent enough to understand that only the models that depend on raw wizards need to be rebuilt. Fusion's smart enough to know that these other 3 don't need to be rebuilt. So if your job selects a handful of models, depending on a selector that you select, that you use in your job, Fusion will know which models to reuse and which models to actually rebuild, depending on which source data was actually updated. We're also able to configure SLAs. Let's say fact orders only needs to be rebuilt every 24 hours, and it was just rebuilt 3 hours ago. Even though some of the upstream data has been updated, Fusion won't rerun this job until we need to meet the SLA that's configured on this job. Next, we can configure Fusion to run when any or all upstream data have been updated. So Fusion is smart enough to know that the 3 models down here, staging orders, staging wands, and fact orders, don't need to be rebuilt because we've configured them to run only when all sources have been updated. Fusion's also smart enough to help handle concurrent jobs running on the same models at the same time. So if you have 2 jobs that both require fact orders, Fusion will put a lock on fact orders until one job finishes, so the next one can then run afterwards to ensure that these concurrent runs don't interact with each other. Cool. And so we've heard a lot of feedback about people jumping back and forth between tools in dbt platform to do their data discovery. Here, I have Insights, our data discovery platform, where users can quickly query against refs in their project. And here, we can show how fast Fusion is at delivering the information that you've seen. So in this ref, we're able to see what columns there are. We can quickly change the ref that we're looking at. And immediately, we know what columns there are directly in Insights. This is the same experience you see locally, but now in platform. And Insights just reached GA today. And now let's say we want to do a sum of order totals by customer from raw orders. As soon as we type this in, Fusion knows that we're missing an aggregation, or a group by in this aggregation query. And this is all without ever actually running a query. And you can do your data discovery in platform and go right back to authoring your data pipelines in dbt platform without ever leaving. Fusion really makes using platform super snappy and fun to use. And we're really excited for you all to try it. I'll hand it back to Benoit to talk about what's next.
Yeah, so we showed you what we've been doing so far, what's already available, but we also wanted to give you a quick idea of what we're going to be working on. As Annie showed you, this is what's been delivered. A lot of it is getting to parity. And getting to parity between dbt core and Fusion is not a little thing to achieve because we have like so many adapters, we have so many configuration in dbt. So it is a huge work that needs to be done. But when this is done, when we have parity and when we start building on top of this Fusion engine, we'll be able to also achieve new things that were never possible with dbt core, but that we will be able to bring to the dbt ecosystem via the Fusion engine. So some ideas that we have, this is not something that I can promise is going to come in the next few months. Like I'm not even a PM, but I know that there are discussions about bringing this to the Fusion engine. One of them is around governance and quality. What SDF had in the past is the ability for people to tag some of their columns as sensitive. So for example, with some PII data, and then having the ability to see everywhere this PII data is used in different models. So it gives you like a really great overview of which models contain some sensitive data, which models maybe need to have some rollover security or need to have some hashing on those columns. So this is something we want to bring to Fusion the same way it was in SDF. Other thing that we want to bring on the governance and quality side of things is the ability to, now that we understand SQL, to be able to tell how similar our different models are. Today, I think one of the biggest struggle with dbt is when you have many models, you don't know if like a given logic has already been put in place. You don't know if somebody else has already defined this business logic. With Fusion, we want to be able to tell people like these two models are like 80% the same. If two models are 80% the same, I would recommend people then to maybe combine them together. You don't want to have the same logic defined in different places because this is likely how things start to diverge. So with Fusion, we will be able to give you some of these numbers and be like, these models are very similar. Are you sure you don't want to combine them together? On the other side, we also want to bring some reduced cost, and we want to improve even more the velocity that people have when developing. We mentioned this morning something that is going to come soon is what we call slimmer CI, so the running CI/CD, but with only the models impacted by my change. Today, if in my model, in my project, sorry, I change a staging model and I just add a new column, well, CI is going to run all the downstream model of this staging model, even if the change is not impacting those models. Like, especially in the context, let's say, of data vault, for example, it can generate like a CI job, which is very huge for the little change I've been doing. With slimmer CI, we'll just run the models that are actually impacted with the change, which in some cases, I believe, is going to reduce like CI cost and time by, I don't know, at least 70%, knowing like what we've seen so far. We talked about the fact that now we are also able to know which tests need to run, need to rerun or not. So for example, if you define like different columns as being like unique and not null, if there is no transformation between those two tables that mean that you're doing a join or anything, then we don't need to retest the downstream one. And we already know that the upstream one was unique and not null. This is the same in the downstream one. And another thing that I have actually seen demos of, so it is not available yet, but hopefully soon available for everyone, it is the ability to run the unit test locally. So today we have unit tests in dbt, but we still have to send them to the data warehouse to be able to know if the unit tests are passing. It is pretty fast, but it can still take like, I don't know, 1 or 2 seconds to run this test. Soon, we want to have the ability to also run those tests locally. So you wouldn't even have to connect to the data warehouse to run your unit test, and it is going to change the time it takes to run those unit tests like by an order of magnitude. And I've seen demos where running like 10 tests is done in less than 1 second. So I think it is going to change the way people use unit tests, and it's going to make them even more useful in the world where we can run them for free and extremely fast. So I think it is going to change the mindset of people when developing in DBT. And another idea that I know people have been talking about, and it's something that also comes from some abilities that SDF had in its CLI, is the fact that SDF had the ability to create like some, let's say, fake tables locally in a fake information schema. And those tables were containing all the information about your project. So it was containing like all the list of all your models, all your columns, all your transformation. And there was a feature that allowed people to write queries on top of those tables to then do some checks on your project. So you can use it as a way to define rules about your transformation. So all my, let's say, staging models need to be linked to like a source. Well, this can then be, you can write a query on top of this information schema to make sure that your modeling is following these rules. So for people familiar with the DBT project evaluator package, that this is kind of like a better version of it, where we wouldn't have to go through like some hoops we go through for a DBT project evaluator to get this information. This would come straight away from Fusion. And I imagine a world where this could be maybe even a pre-commit. So whenever somebody writes something, we would run this test locally before and make sure that let's say, we are not breaking some of the rules that we've defined whenever we build a new model. So again, this is a way that I truly believe that is going to change the way we build, making it more efficient, and not like having to run some CI like for something that we know is not correct. Like we will get straight away the information from the development terminal. And this is like just a few ideas. Like there is many more that will come. As we mentioned, that we need to work on the parity between DBT Core and Fusion, which is a big work. But we also have like then all this bright future coming up. This is all that we have for today. Thank you for joining. For people who are willing to dive deeper into Fusion, we have a session at 2:30 p.m. A roundtable. So Annie and I will be there at 2:30 p.m. It is a 1-hour session where you can ask us questions. It's going to be more interactive. You can ask us like how things work, and also it's a way for people in the community to talk about their experience running Fusion. So if you're interested, yeah, join us at 2:30 p.m. It's in the agenda. And thanks for joining, and thanks for being here.
Thank you all.